Assalamualaikum and a very good day. Today is my final lecture, okay, on the flow measurement. And today I would like to cover the topic of ultrasonic flow measurement. Okay, this will be the last lecture for the AC lecture, and I hope that everybody will be ready for this. Okay, ultrasonic flow meters. Okay, this is one of the method where we measure the velocity of a fluid with ultrasound to calculate the volume flow. Using ultrasonic transducer, the flow can be measured. Can measure the average velocity along the path of an emitted beam of ultrasound. By averaging the difference in measured transit time between the pulses of ultrasound propagating into and against the direction of the flow, or by measuring the frequency shift from the Doppler effect. Okay, this topic is interesting because next time, okay, maybe especially in the medical imaging, you will also introduce to the topic. Okay, so this is like an overview. Okay, how does we use ultrasound? Okay, to do imaging. Okay, but here in our case, okay, we will use ultrasonic method to measure the flow meters. So what are the transducers that we use? Okay, we use a piezoelectric material. Okay, usually like lead zirconate titanate. Okay, PZT. So we have two types of measurement. Okay, near field. Okay, the beam is largely contained within cylindrical outline, and there is a little spreading. Okay, the intensity, however, is not uniform. There are multiple max and min. Okay, within the region caused by the interference. Okay, and then there's a far field. Okay, the beam diverges, and the intensity is proportional to the square of the distance from the transducer. Okay. In the application, we should avoid far field because of its lower spatial resolution. So we try to have it near field. Okay, to achieve near field, we must use a higher frequency and larger transducer. So we have many diameters of a transducer to achieve this. So this is one of the, okay, there's a few examples of transducer, okay, the 5 millimeter, okay, and 2 millimeter and 1 millimeter, okay. Near and far field for various transducer diameters and frequencies, okay, beams are drawn to scale, passing through a 10 millimeter diameter vessel, okay. Like I told you just now, transducer diameters are 5, 2, and 1 millimeter, okay. There is a few equation that is responsible here. The near field distance, okay, and equals to d2. What is d2? Okay, is a transducer diameter, okay, transducer diameter, okay, and divided 4 lambda, which is the wavelength, which is our wavelength, okay, and then there's another equation here. Formula here is sin theta. Okay, here, okay. We divided by 1.2 lambda, the wavelength, divided by the transducer diameter. Okay, so here the solid lines are for the 1.5 megahertz, and the dashed line is for 7.5 megahertz. Okay, so this is a typical ultrasonic blood flow meter diagram. Okay, we have the transmitter and then the receiver. Okay, and then this is how this work. Okay, okay, transit time for the flow meter, laminar flow equals to 1.7 nu, and turbulent flow equals to 1.7 nu. It is okay, it can be invasive, can be operate with either saline or blood as fluid, okay, and do not require particulate matter for scattering. So maybe we can, okay, saline maybe we can use for modeling, okay, and blood, and blood if you want to measure a, a, a typical case lah, okay, for biomedical engineering. Okay, so how you measure it? Okay, t time, okay, equals to distance, okay, divided by the velocity, and this is the equation. Okay, and then if there's what we call the difference of time. Okay, and this is the equation. And C, okay, we will look at the C after this. We will look at the C after this. Okay. Ultrasonic transducer configuration. Okay, A transit time probe requires two transducers facing each other along a path of length D. Okay, so length is D. Incline from the vessel exists at an angle theta. The hash region represents a single acoustic pulse traveling between the two transducers. In a transcutaneous probe, okay, both transducers are placed on the same side of the vessel, so the probe can be placed on the skin. Beam interaction is shown, okay, hatch, okay. Okay, so for C, any transducer may contain a plastic lens that focuses and narrows the beam. Okay, this is how this is look. Okay. For pulse operation, the transducer is loaded by working with a mixture of tungsten powder and epoxy. Okay, you have it looking like this. Okay. This increases losses and lowers the Q, the quality, the loss quality. Shaded region is shown, okay, for a single time of range getting, and E, a shaped piece of lucite on the front loads, okay, in the front loads the transducer and so refracts the beam. A transducer placed on the end of a catheter beams ultrasound down the vessel. So this is invasive, okay, like okay, this is invasive type, okay. G, for pulse operation, the transducer is placed at an angle. So this is how does it measure the blood flow. Okay. So okay, I told you about the C. Okay. This is for okay. For continuous wave Doppler flow meter, the frequency of received sound is lower because of Doppler effect. Okay. For small changes, the fractional change in frequency equals the fractional change in velocity. So you have this equation. Okay. Fd divided by F naught. Okay. Equals to U and C. Okay. So here that I told you about the C. Okay. The shift occurs between transmitting and the moving cell that receives signal, and between transmitting cell and the receiving transducer. Okay, C, it is given here 1500 meter per second, and U is equal 1.5 meter per second. So we just insert it here. Okay, so C is a speed of the transmitting cell and also the receiving transducer. Okay. The velocity does not act along the same straight line, so we add angle vector. So if like you have seen the diagram before, it is governed by the angle, okay, between the beam of sound and the axis of blood vessel, okay. And this is the how the block diagram of your flow meter. Okay, you have the probe, okay, and the oscillator. Okay, the RF radio frequency amplifier, it detects, okay, the oscillation, and it will try to, okay, and then you have a AF amplifier, zero crossing detector, and then you have the flow password, and then you have the recorder, okay. So this is all the formula from the last page, okay. And then, okay, in the simplest instrument, ultrasound is beamed through the vessel walls, okay, back scattered by the red blood cell, and received by a piezoelectric crystal. So this is how does it work. Okay. Okay. For this is the last one. Pulse Doppler. Okay. Transmitter is excited with a brief burst of signal. Transmitted wave travel in single packet. Transmitter can also be used as a receiver. Okay. This is like one probe and you have both of them, transmitter and also the receiver. Okay. Delay between transmission and reception is a direct indication of distance. Doppler shift at various delays can give velocity profile across the vessel. Laser Doppler flow meter. Okay. Laser beams. This is the wavelength. Okay. Light through fiber optics into the skin. Red blood cells in the skin. Okay. Frequency shift the light and cause the spectral broadening. Reflected light is carried by fiber optics to a photodiode for processing. Okay, so with this we end our asynchronous lecture. Okay, thank you for your attention. Thank you very much.